So hello, welcome to make a video about C++ safety. This guy just Alex Gaynor. He's saying he's a frequent critic of memory of safety. No, he's not a frequent critic of memory safe languages. He is a Rust advocate, right? He is a Rust zealot, and he believes using C++ violates human rights, right? Violates human rights, right? Just you use C++, you are human rights violations, right? Okay, so the most interesting thing I would quote unquote interesting. So he said modern C++ won't save us, right? So I really want to see whether those things we can use whether it's valid or not. Okay, so let me just find out every example of he's reading here. He wrote here. Okay. So first we're going to do string view, right? No, I shouldn't call string view, but just use that as an example, right? If I remember correctly, GCC won't find it, right? GCC won't find it, but you can always use sanitizers to find it. But you might say sanitizer is not good enough. I want to just do that at compile time, right? So the code compiles. But if we use clang, yes, it can just tell us what's going on here. I think clang probably won't work with sanitizers. Equals area D. You can see the compiler just refused to compile. No, not refused to compile code. It actually can just detect the bug we have here. So it's just invalid to say. It's just completely invalidated, right? Now, so this example is just totally wrong because we can see the compiler can detect those things, can detect any bugs related to string view. Okay, so let's just try the second example. The second example is not be able to detect it, right? But we can always use sanitizers. Okay, I use a cross compiler. Because I never even wrote this code, I never use any smart pointers. Smart pointers are bad. I don't know why people would use this smart pointers, but we can see whether the compiler can detect it, right? The compiler can just detect the problems. If we don't use the maximum optimization, we just use let's just O0, OG, just enable. Let me see whether we can just get us more information about which line that have the problems. Okay, you can run the code. Okay, I don't know why people just don't do that, right? Okay, I think if it is correctly, we should be able to see the code we have here. Which line? Oh, you can only detect sanitizer. So. Yes, even cross compiler. I can even use the cross compiler to do those things, right? It's not even you have to use a native torsion just to compile the shit here. Fsanitize. This should work, right? We just OG. It should just provide a debugging information. And we'll put here an it should compile. It should compile, or probably the executable is here. I think we just copied the wrong executable. I just copy from the file itself, and we give it a go. I think we can find which line they find the problems. It told us the problem. Okay, maybe I shouldn't just put any O here. I should just put even O. I think probably also related to stripping. It stripped all the debugging information. Let's just use G. Okay, let me see whether we can detect the bug here. I think we should be able to. Yeah, it told us which line we have the bug, right? It told us which line we have the bug. It's exactly the lines we have is 616 line.
Yeah, it's line 16. It told us you dereference a pointer, so it tells us the thing, right? I can even use that to do cross compilation. I don't know whether people say cross compilation is hard. It's not hard, but that's not an interesting part. You know, I always just turn on sanitizer and whatever. The most interesting part is a shit he wrote after that. Okay, it's about the dereference of the to optional. Okay, now in fact, it's just simply untrue to say you have the problem with still optional. Okay. What he's saying is that you can just dereference a uninitialized variable, right, with still optional, and you can have the problems. But let me just, I think we cannot just directly compile the code. We can only compile in the main, right? Okay, let's just replace it with in the main. Now, in fact, okay, I'm using a native program right now. The sanitizer doesn't work on Windows, right? But we can just always use sanitizer. I can just cross compilation. It's not a problem. But if you look at this executable, yeah, it's just uninitialized variable. I think it's in uninitialized variable. It should be uninitialized variable. We don't see any crashing here. But if we use g leave cxx assertions equal 1, you can see the program crashes, right? So we can add checks to that, right? It's not like the Russell is saying the world is dead. We have the right. It's not doomsday scenario, you know. Same thing with this. Okay, same thing with this, and you cannot just dereference a new printer. Okay, you cannot. And this is funny. Why do you put optional inside a unique printer, right? You should just use unique printer, right? Why you put unique printer optional? This is also detectable. I can guarantee that it is always detectable. Use the memory. We put memory header. Then what we did is just return F. Okay. Probably I should output something, right? I should output something with fast.io, for example. Yeah, just use fast.io to output, okay? So we going to output the thing here, because I mean, if you have a UB, you probably just going to get a huge crash with it. Oh, we don't do this, okay? What we're going to do is just print f, okay, printf, then to reference it. Okay, we'll just reference it. Okay. Okay, we compile, right? You can see the code refused to compile because it adds the new printer checks. Can we see whether we can just not enable that, whether we can output something? It still crashed. This is an undefined behavior crash, but if we put glibcxx equals 1, we can just see a crash. It just directly crash. I think I should put that in a console. I should just use a cross torsion, for example. Now here we go. We have an executable. Okay. So we can just put an a.txt. You can see it's about it scroll down. So if you want to add any new checks, you can just enable the glibcxx assertions. Okay. You can always give your check. Okay. Then we can just copy that. So this code should not compile. It's still about it. It's not about it. Probably because it doesn't work here. when you remove entire stuff, or you can always do a check, or you can just abort, right? It won't just abort the executable. Segmentation fault, right? We see a segmentation fault, okay? But if we put glibcxx equals 1, we can just see the executable crashed for that reason, the particular reason. You might say, well, we cannot even see any verbose information here because I built the GCC with no verbose. We won't see any verbose information here. You can see we just disable the verbose here. Disable libs to C++ verbose, right? We disable the verbose, so we won't see any stuff here. But adding that check just won't increase our binary too much compared to Rust, for example. Rust just horribly crap. But they think they're just 100% safe. But I want to show other examples, okay? These other examples, we just examine them one by one. So we added and it checks. You can see this is basically crashing here. Because we dereference a null null, then the glib C++ will add checks for it. Then we get a crash. So next is the final example, just the worst example, okay? He's saying this toSpan has no indexing, okay? He's saying toSpan has no add, okay, has no add, and does not provide or any method that performs the bound checking. Is that true? That is completely false, okay? That's completely false. That is completely false. So we can just see the code here. This is my favorite example. I think I showed that last time with Rust, right? Not this. Not this. Not this. Okay. Or maybe I can just put here because okay. CC, okay. We put span full, okay. It's my favorite example. Okay. So what you're gonna do is S0 equals 0 equals 4, S1 equals 5, S2 equals 6, S3 equals 7. Okay, let's do something, whatever we can. We can do whatever we can. Okay. 10 x5 is equal to 15. Okay. So let's just compile this code. Okay. Okay, so you can see the code is vectorized, right? Because it just, I think I showed that example in my previous videos, similar examples. But what we want is that we want to add bound checking. So if you want to add bound checking, what you can do? Very simple. What you can do is just like I did in the optional examples, we can just add this. Okay. Now we can see the compiler adds checks here, right? And it adds all the checks here, and it calls in and call about. Okay. So what about the code size? Let's just compare the two code size. Okay. So no bound checking is definitely even faster, right? Because you can factorize. I think that's something C++ compiler could just further improve. But you can see it's completely untrue to say you use span, you don't have bound checking, right? The behavior standard say is undefined behavior, right? That does not mean the compiler, right? If you have an index, you have undefined behavior, but that does not mean you can not ask the compiler to add bound checking, right? Because that's undefined, right? You can add bound checking. That is also valid. right? That's undefined behavior doesn't mean it is always do bad thing, right? It can you exploit that undefined behavior to do good things, like this is doing, right? So yes, we can add bound checking to the code here, right? You can see we have the bound checking we have, and we have the about here. If we want to just make the code better, what we can do is just switching back just to that, right? They just we have the bound checking, right? We do have the bound checking. We can see the compiler do the compile CMP instruction and call the instruction to call an about. And in fact, this is a very good tower, right? If you want safety, you can just use that, right? If you don't want that safety, then you don't want safety, okay? Now, in fact, you can even argue the opposite, right? Because Rust unsafe never does any checks, right? Rust, if you use get mute uncheck, right, it never perform any bound checking, right? You cannot do bound checking to get mute unchecked because get mute itself is implemented by get mute unchecked, and I've checked the source code. It has no bound checking. So if you are saying that using C++ violates human rights because span does not perform bound checking, okay. Unbounded checking. This is completely false. If you're saying that, I can say Rust is, you cannot hold Rust say it right either, because you use this stupid example and you have no idea what you're talking about. You don't even know there's a tower to add C++ that can check bounds, right? Right. And it's check bounds for all containers, including Vector, including DAC, right? Let me see whether we can add bound checking to Vector, right? We have the bound checking here, right? If we disable that, we don't have bound checking. Okay, it looks like the tower just doesn't work. So yeah. Okay, we'll just do this. Okay, it doesn't matter whether it's 1 or 0. Okay, it's yeah. So it's simply untrue to say C++ Vector or span just doesn't do any bound checking, and we do bound checking even for the so-called unchecked part. Right? We do bound checking for both part, right? So it's completely false to say C++ container cannot do bound checking, won't do bound checking. That is completely false. Okay, it's completely false, right? So, okay, this video is not to defend C++ for memory safety. That's not my point. My point is that you should not use this stupid C++ example to just. Right, just to promote Rust, right? It's a very bad thing. You cannot just blaming people like me who use C++ who violates human rights, right? And I think, right, this completely makes no sense. I mean, if you're blaming people who write bugs violates human rights, then everyone writes bugs, right? Everyone is a human rights violator, right? So if you're using C++, you can use these assertions. It adds bound checking for you. And it's pretty good. You want to get an exploit here, right? If you're using C++ containers, don't use smart pointer. Smart pointers are bad. So if we use C++ containers, whatever, you have the bound checking. Of course, this also has problems, like you cannot use to span in freestanding environment, right? I think that's something that standard have to deal with. But to say C++ has no bound checking, the modern C++ won't save us. It's, modern C++ won't save us. It's save us. It looks like we are going to die by using C++, right? We are going to die. We are going to die tomorrow because we use C++, right? Mono C++ won't save us. You cannot save us by using Mono C++. You're only using Rust to save. Despite Rust has a lot of memory CVEs too, and Rust focusers refuse to talk about those things. They don't even add bounds checking to get mute unchecked. You cannot even verify it, right? And I think this bounds checking is also pretty cheap compared to Rust. If we just do the same thing in Rust, just so stupid, you know. We can add bounds checking to both ends, right? They cannot, but Rust cannot, right? Rust cannot just add things for both things. And they're just complaining how bad C++ is. I think it should be this one. Weird. I think it is. Okay, S. Right. Okay, it's extremely long, right? Just even doing that is extremely long. O2, okay. Okay, just add O. Right? And it's generally this string here. Compared to C++, we don't even have those things, right? But the checking is much cheaper than Rust in general. 1, 2, 4. Because they will generate lines for every index, you know. They will generate line. Which line you have the problems? They give you a different string. Why with C++? I think because I'm using no verbose build, we have the things. But even with that, we can see C++ with bound checking is actually much shorter than Rust in general. Let me just show the examples here. What I find is that here's a bug here. Here's a bug in the old version of the compiler. They still haven't fixed it. Yeah, they need not fix it. Great. So I can just test. I just know that bugs anymore. Let's just see what we can do. Yeah. See that? What about the compiler things? It's extremely good, right? If you compare to Rust code, even with bound checking, Rust generates 4 times more instructions than C++, right? 4 times more instructions than C++. Now you might say, I think clang won't work because they're probably not using the same library. And I think probably they're using an old versions here. Yeah. Okay. Both GCC and clang generates 24 lines of instructions. I think they will also emit a library function. Oh no, probably they also build it with verbosity. I don't know. But if we just compare the bound checking with C++ versus Rust, the Rust generates 4 times more instructions plus all this format string, right? Okay, the C++ is basically nothing, right? It's doing exactly what you want. Although we can argue compiler should do better, should automatically do some move here, just to make it vectorized, right? So we can get an even better checking here. But whatever in which case, okay, what case we are, we can see Rust is just actually pretty bloat, and even with C panic equals about, right? And the worst part is that if you're using unsafe function, if you're using unsafe function, if we put in unsafe block, right? We put them unsafe. We don't want to use any bound checking. What we can do is using unsafe block, then get mute unchecked. You know, it's so verbose. The language is so verbose. You know, it's just get mute unchecked. Why can't compile? See the information here. Get mute unchecked. s equals get mute unchecked. Let's just put get mute unchecked here. No, it's not get unchecked, right? It should be get mute unchecked. Always. Mutable reference, probably mute is before that. Yeah, it looks like this is the case, right? So equals 4. It's pretty verbose. I mean, even you want to just see whether bound checking would affect performance, then you have to rewrite your code. That's just pretty verbose. That's something just, you know, it's nowhere like Rust folks saying you're 100% safe. You have to just test whether binary this will affect performance, right? You don't know. They provide both things, and you're deeply confused by those things. I think that's exactly why SPAN has no app. It's not actually because we don't care about safety. It's because we can just using only one function that can deal with everything. Wait, I think I did mention that in my previous video. Yeah. So yeah, it's the same thing, but why you cannot just add those things? Usize. What the get mute unchecked? What was that get mute unchecked? It should be a get mute unchecked, right? Get mute unchecked. Who thought that's a good idea? Just get unchecked. Okay. Get unchecked. No, you cannot assign, right? Because it is, yeah, my memory was absolutely correct. It was get mute unchecked. Get mute unchecked. Anything wrong here, or just like can I use slides? Just too verbose. The language is too verbose, right? Even doing basic things, it's just too verbose. Whatever, just don't care. And if you look at those things, right? I just don't want to use the shit anymore. You know? Just create shit, right? You have no way to just add bound checking to unchecked functions. Okay. They won't do that, right? Because we already do the checks. Why you just not check again, right? They will think that way. Okay. Whatever. I don't care about what they're thinking, but yeah, that's exactly. I think this is a fair comparison, right? Rust generates 4 times more instructions than C++, even for bound checking, right? We have the bound checking we already have. If you check, you can use both GCC and clang, they all work, right? And also, all the Linux distribution just build that with this. Okay, it looks like they build that with verbose too, because if you don't see verbose, we should see a verbose here. Probably, I think they do that too. Probably that's not something what you can do with your compiler. I think probably going to be longer, but it won't be that long as Rust. Okay, the Rust is just ridiculous for bound checking. Okay, so that's it. Okay, I think this video is probably going to be useful, and if you're using that, I think every compiler, Leap C++, MSVC, STL, they all provide bound checking, optionally bound checking. to all the problems, to nullpter checks, it checks nullpter, it checks nullpter, all those things. Okay, it's highly recommended you enable this tower if you really care about safety, or you want to just verify whether the safety would add performance burden to your code. You can just enable that tower. Enable this tower, and now I think now the glib C++ assertion is actually is by default built with Fedora. Fedora is not built that with, including Red Hat. Right? I think probably all the applications in the future, at least in the Linux distribution, they will add bound checking. Okay. This is a tower that won't affect ABIs. It's a very good tower, and if you care about it, you can enable that too. So it's clearly false to say people just C++ has no, modern C++ has no bound checking. It's just false, completely false. Okay, so that's about the whole about the video. I hope you enjoyed the video, and yeah, see you next time.